I mean, obviously you're going to see some bubbles because that's the steaming process. That's like air forming out the process of. Well, there's an interchange there. No, there's an interchange happening with steaming. So as that, if you think about it from the air's perspective, the air perspective is I'm dry and cold. So I need hot from the heat and wet, hot and wet water. And so that equilibrates the air. Well, at the same time, the water is saying I need cold and dry air to get into the water. So it's interchanging the air bubbles into the water.
Air bubbles.
And
it's boiling. The air bubbles. I mean, it doesn't bubble unless it's boiling. And hot. My tub and my, that's got steam coming off of it. It's not bubbling. It's just got steam coming off of it.
Well, that's because it's an open system. So the water is sublimating off to try to fill the entire system, which you would keep filling the entire apartment, But in this, it's a closed system. So eventually, once the closed system gets equilibrated, then there's an interchange happening. So the water and in the air the water's being replaced by oxygen in the water, and there's bubbles, and the oxygen in the air is being filled with water molecules as well. So they're both equilibrating each other. They're balancing.
You're saying in a closed system, the water will bubble because of
it starts interchanging
with temperature, and the bubbling action is actually not boiling.
And then it's interchanging. I mean, it might be called boiling, but yeah. But boiling itself is like, boiling literally means a temperature of like 250 degrees Fahrenheit. Like that's the literal definition of boiling, is a certain temperature.
Yeah, doesn't
boiling
it?
Point.
It takes it, and what that is this breaking up, and then this releasing of the gases and the breaking apart. Doesn't it? That happens at that.
A boiling point is where a solid becomes a liquid, or a liquid becomes a gas.
Right.
So when it changes state. Mm-hmm. And so like back to the bubbles in the water, it's the temperature could be like 65 degrees. You could have 65 degrees and still see bubbles given the right gradient. So if the temperature of the air was negative 35 degrees Fahrenheit and you heated the water to 64 degrees, it would still bubble and steam. You'd see steam because it's the gradient, it's the difference between the two that creates the bubbles and the steam. Because they're trying to equilibrate each other. So, and the key with proteins is to keep them around the living range. So as long as this water that the plants are being exposed to stays within a living range, like, between 58 degrees and 112 degrees.
Bubbling? Like boiling, what you're saying is not boiling.
Yeah, technically it's boiling, but it's not denaturing proteins because it's not hot enough to denature the proteins. So technically, yes, the water...
Okay, technically it's boiling, but it's not boiling at a boiling temperature.
Well, the water's changing state, so technically it's boiling, but it's not heated to the point where the proteins are denaturing.
Well, we're not talking about proteins. We're just talking about what the water's doing.
Yeah, but the key is what we're doing to the proteins. That's why that's our point for this system, is we want to preserve the proteins. And the proteins will break down at high temperatures, say 135 degrees. And so to preserve that, we want to create a steam system whereby the plant is softening and the membranes are opening up, but the proteins are not dying. So we want it to be a steam-like system, ionic interchange between water and inside of plant cells, but not hot enough where the proteins are dying. So we are creating a system whereby the air is cool enough that's in there and dry enough, and the water is hot enough and wet enough where there's an interchange so that the plants are being cooked, but the proteins are staying whole and living. Yes, technically the term boiling, if the water's changing state, it is boiling, but it's the temperature that matters. So I don't know what temperature that is. You'd have to put a little temperature thing in there, like
maybe
stick it in the kale.
Maybe it's not bubbling. How do we know if it's bubbling or not?
I mean, we can
have to do this in a glass.
Yeah, you could do it in a glass and you could see. I mean, I just imagine it is because we've got the steam coming up to the top.
Well, yeah, and I'm thinking it may be with that amount of heat and just so little water, that pan is getting, and everything is kept like that, so it's even hotter than if it were a pan that didn't have a cover on it. So maybe it's
not necessarily with a pan
enough.
Without a cover. You get really hot on the bottom, like wherever the plant was contacting the bottom.
But you're talking to somebody who's really, really experienced with sauteing and with steam, this method of steaming greens, wilting greens, and I feel like if you've got this movement, if you've got movement of the plant, it's kind of like it's steaming because it's moving. It doesn't have the opportunity to sit there and get really, really heated up or burned. I don't leave them if I'm doing that and wilting it, and maybe put often I'll put a little bit of water to help sort of with the steaming, and then also a little bit of oil, or I'll put a little bit of oil after. But with the movement, I
see that. But at the same time, you've got to stand over it and stir it, where in this system, the steam's doing that itself. The steam's swirling around in there and evenly cooking the greens, instead of you having to stand over it and swirl it. And it's preserving the water too, because with your system, if it's open, when you're stirring it, you keep losing water to the steam, and so you have to keep adding water. I mean, obviously you start out with more water, so by the time it's gone, but this way you use less water. Like, we use that much water. It's doing the stirring for us, and it's cooking the system, and we can walk away from it. Whereas with that system, we have to do it and consciously manage it. Otherwise it'll burn on the bottom. So, I mean, with this one, you kind of have to do the same too. It's nice to like stir it so the top greens go to the bottom and get the more direct steam heat than just the secondary heat that is curling over and inwards.
It's also a matter of time. I mean, I could have, in about 3 minutes, had it done.
Well, the thing is, that's probably been done in about the same time that we've been discussing. See?
I'm at those little chunks here. Yeah,
That's pretty cool how we steam that entire system.